SSERVI Origin and Evolution of the Moon course. My name is Jim Head at Brown University, and together with David Kring at the Lunar and Planetary Institute, we're sponsoring this SSERVI course, the Solar System Exploration Research Virtual Institute. We're very pleased at the recent activities on behalf of NASA. We're all very excited to be going forward to the moon to stay. And we're very, very fortunate to have with us today NASA Administrator Jim Bridenstine, who will speak to us on Presidential Space Directive number 1, to the moon to stay. We've had a really good set of lectures coming up to the present one, looking at a wide variety of the transformative lunar science questions, and also the history of lunar exploration, a whole series of things about the data that we have so far, and that we are looking to complement in the future for major, major transformative lunar science discoveries in the future exploration of the moon as outlined in Space Directive number 1 and the scientific and commercial commitment that goes with that. So let me say that we had a really wonderful Geological Society of America meeting the last 3 days. Apollo 17 lunar module pilot Jack Schmitt was there. We had a great time throughout the sessions and drinking beer in the afternoon as usual, as geologists tend to do. And Jack will be talking to us about the future exploration of the moon as well, the road ahead from his perspective of doing field geology on the moon on December 19th. So without further ado, let me introduce Greg Schmitt. Greg is the director of the Solar System Exploration Virtual Institute, and he will say a few words about SSERVI and introduce Jim Green, the NASA chief scientist. Over to you.
Thanks so much, Jim. We're just incredibly honored today to have the NASA administrator, Jim Bridenstine, shares both NASA's plans and his own vision for our return to the moon, something that excites us greatly at SSERVI. SSERVI is a virtual institute with headquarters at NASA Ames Research Center and teams of the best and brightest lunar scientists and small body scientists across the country and partners across the world. Our mission is simple. Research both the science that will enable and enhance human exploration of our solar system and discover the unique science that can be done when humanity takes its next steps forward to the moon and beyond. A key part of this is education and educating the next generation of women and men as we become a multi-planet species. And that's the purpose, really, of this wonderful class. I'd like to now turn it over and introduce the NASA Chief Scientist, Jim Green.
Thanks very much, Greg. And indeed, it's my great pleasure to introduce Jim Bridenstine, our lecturer today. Jim became the NASA administrator in late April of this year. So, and I became the chief scientist soon after. So another one of the Jims joined the team.
There you go.
So Jim actually completed a triple major at Rice University and then went on to earn his MBA at Cornell. Jim's career in the federal service began in the U.S. Navy, flying the E-2C Hawkeye off the USS Abraham Lincoln aircraft carrier, which can't be an easy thing. There was also many combat missions that Jim flew in Iraq and Afghanistan, and he accrued more than 1,900 flight hours and over 330 carrier assist landings. He later moved to the F-18 Hornet and then flew at the Naval Strike and Air Warfare Center, which is the parent command of Top Gun. After transitioning from active duty to the U.S. Navy Reserve, Jim then returned to Tulsa, Oklahoma to be the executive director of the Tulsa Air and Space Museum and Planetarium. While in the Navy Reserve, he was promoted to the rank of lieutenant commander, in addition to flying missions in Central and South America in support of America's war on drugs. Most recently, he transitioned to the 137th Special Operations Wing of the Oklahoma Air National Guard. Now, Jim then went on and was elected in 2012 to represent Oklahoma's 1st congressional district in the U.S. House of Representatives, where he served on the Armed Services Committee and the Science, Space, and Technology Committees. So Jim's talk today is on the President's Space Policy Directive 1, and it's all about going to the moon to stay. So please welcome Jim Bridenstine.
Well, thank you, Jim, for the introduction. I want to make sure my audio is working. Is everybody able to hear what I'm saying? Good feedback?
Copy that.
All
Sounds
right,
good.
Fantastic. Well, it's an honor to have the opportunity to be able to address this group of students. I understand that these are the students that we're looking for in the future to lead space exploration, and of course, as the NASA administrator, I'm keenly interested in that because there's a lot to do, and we need some of the best and brightest. So it's an honor to be here. Thank you, Greg, for inviting me to participate. Thank you, Jim, for that great introduction. One of the great things I get to do as the head of this agency is I get to have Jim Green come into my office from time to time and share with me some of the great science that has just been discovered. And I've been the NASA administrator for 6 months, and I'm telling you, every day we're discovering something new. And it's thrilling, and what an honor to be at the helm of this great agency with so many amazing people. Some of the things that Jim has brought to my attention just since I've been the NASA administrator, we now know that the methane cycles on Mars are commensurate with the seasons of Mars, which is, again, I say this over and over again because I don't want anybody to suggest that I'm making news that's inappropriate, but that doesn't guarantee that there's life on Mars, but it increases the probability that there could be life on Mars. We know that 10 kilometers under the surface of Mars, maybe even deeper, there are massive aquifers of liquid water under the surface of Mars. And we know that there are complex organic compounds on the surface of Mars. And all of these discoveries have been made just since I've had the opportunity to be the NASA administrator for the last 6 months. So of course I will take credit for all of those. What an amazing opportunity to be at the helm of this agency at this time, and to have space policy directives coming from the White House that are focused on the moon, and not just going to the moon, but doing it in a way that we've never been able to do before, doing it in a way that is sustainable. So if you think about what the President's first space policy directive was, he said we're going to the moon, and he said we're going to stay. So this is actually it. So when you think about Space Policy Directive 1, what this did is it updated the national space policy for the United States of America. So, which is a multi-page document, and it goes into a whole host of space policies from civil space, commercial space, national security space, and really the only thing the President did is he changed this one section that he added here. And he says that we're going to lead an innovative and sustainable program of exploration with commercial and international partners to enable human expansion across the solar system and to bring back to Earth new knowledge and opportunities. Beginning with missions beyond low Earth orbit, the United States will lead the return of humans to the moon for long-term exploration and utilization, followed by human missions to Mars and other destinations. I underlined 5 words that I think are incredibly important to this new space policy for the United States of America. The first one there is sustainable. So I am charged as the head of NASA to lead an innovative and sustainable program of exploration. We're talking about space policy here. And if you think back to space policies of previous administrations, you go back to the Space Exploration Initiative of George Herbert Walker Bush, or the Vision for Space Exploration under George W. Bush. These were space policy directives to go to the moon. And in each case, they never materialized. World events happened, budgets didn't materialize, we got distracted for one reason or the other, and we never went. So what we're trying to do now is something entirely different. I get this question a lot. How do we know that this time we're actually going to go? Like, why is this time different than every other time we've been told we're going back to the moon? Well, here's the thing. We're going to go sustainably. In other words, We're not going America alone, which in the past has been policy, and we're not going without commercial partners, which commercial partners didn't even exist 5 or 10 years ago in many cases. So in this particular case, a sustainable return to the moon means that we need an architecture. When I say sustainable, it means that the program's not going to get canceled because it's not going to go over budget, number one. And number two, this time when we go to the moon, we're going to stay. We're building an architecture where when it's there, it's going to be there for a long time. And it's an architecture that's open, which means commercial partners can plug into it, international partners can plug into it, international commercial partners can plug into it. We want an all-of-the-above approach where the United States of America is leading. That's the first word there, is lead and innovative and sustainable program. So how do we get sustainability? That's the question. That's my charge. How do I get, as the NASA administrator, sustainability? We have seen what happens when we reuse launch vehicles. We know that when we reuse launch vehicles, the cost of access to space goes down. And in fact, access to space for so many others goes up. That's what commercial crew is all about for the International Space Station. We're going to launch next year American astronauts on American rockets from American soil for the first time, but these rockets will not be purchased, owned, and operated by the U.S. government. Instead, we, the U.S. government, we're going to buy a service from commercial operators, believing that these commercial operators will find customers that are not the U.S. government. In other words, we're going to spread the costs, the development costs, the engineering costs, all the non-recurring costs. We're going to spread those costs against many customers. So it's in our interest as a nation, if we're going to have a sustainable program, we want to be one customer of many customers in areas where that makes sense. And at the same time, we not just want to be the one customer of many customers, we also want to have numerous providers competing on cost and innovation for those numerous customers. So if they're competing on cost and innovation, that drives down cost, it increases access, and does all those things that are important. So for a sustainable architecture, we need to use commercial partnerships. In other words, we want to buy services. But also for sustainability, what we're finding is that reusability is critical. Reusable launch vehicles are in existence because commercial partners that are resupplying the International Space Station and commercial partners that are launching crew to the International Space Station, they're competing on cost and innovation, and it's in their interest to drive down the cost and increase the access to space. It's in their interest, and because it's in their interest, they have figured out ways to reuse rockets that are increasing our ability to do more than we've ever been able to do before. Well, that's just for launch to low Earth orbit for access to the International Space Station. When we talk about commercial crew and commercial resupply, we're talking about access to the International Space Station. The question is, when we go to the moon, how do we build sustainability into that architecture? Well, we want every piece of the architecture between the Earth and the moon to be reusable. We want reusable launch vehicles. We want reusable tugs from Earth orbit to lunar orbit. We want a reusable command module in orbit around the moon for a long period of time. We call it the Gateway. This is not the International Space Station around the moon. Some people believe that's what it is. That is not the case. The Gateway is a reusable command module. It's much smaller. It has solar electric propulsion. And because of that, it's going to not only get to certain parts of the moon that we've been to historically, but it's going to be able to maneuver from a near rectilinear halo orbit all the way up to the L1 point and the L2 point and many points in between. So we're going to have more access to more parts of the moon than ever before with a reusable command module called the Gateway. Then we need reusable landers. We need landers that are small so that they can take scientific payloads back and forth to the surface of the moon and back to the Gateway. And we need everything between that and, no kidding, landers rated for human activity to get back and forth to the surface of the moon. So the idea is reusability in this architecture needs to be embedded from the beginning. And in order to achieve that, we're going to maximize the use of commercial capability. So that first word there, sustainable, it doesn't exactly mean reusable, but reusability enables it to be sustainable for the long term. And then that second word there that's underlined, commercial, commercial is really the tool by which these innovations have taken place, because you've got multiple companies competing on cost and innovation, and we're living in an environment, in some cases, where NASA is one customer of many customers. It is also true when we talk about space policy, people know that the lunar architecture requires SLS and Orion. SLS and Orion are not reusable in the sense that the Dreamliner, which is the Boeing spacecraft, is reusable. It's not reusable, Boeing, for basically taking crew to the International Space Station. It's not reusable in the sense that the Dragon spacecraft operated by SpaceX, it's not reusable in that sense. But the Orion crew capsule, our deep space crew capsule, is in fact reusable in some ways. The avionics will be reusable. A lot of the internal components will be reusable, and by EM4, Exploration Mission 4, no kidding, we're going to have the pressure vessel be reusable. So when you think about space policy for the United States, resupply to the International Space Station is commercial. Crew to the International Space Station by next year will be commercial. The question is, going to the moon, how do we build an architecture to the moon? Well, we don't have commercial suppliers right now that are delivering things to the moon. So we are actually building, purchasing, owning, and operating the biggest rocket that's ever existed before, called the SLS, Space Launch System. And the Space Launch System is going to have 130 metric tons of throw weight to low Earth orbit. It's going to be taller than the Statue of Liberty, the biggest rocket that's ever been built, carrying more payload than any rocket that's ever been built. And it's going to be the tool by which we're able to put our American astronauts back into orbit around the moon and eventually to the surface of the moon. It's going to be the vehicle that we use to deploy not only the Orion crew capsule for deep space, it's the tool that we use to deploy the Gateway, which is our 15-year reusable command module around the moon. So that's a lot of activity that we have underway just in everything that I just mentioned. It's important to note that this architecture that we're building for the moon is open. The way we do avionics, the way we do communication, the way we do data, the way we do docking, all of these things need to be available to the public, published online, so that ultimately any nation on the planet that wants to start a space agency, that wants to participate in this architecture, they have the opportunity to do so. When we think about the historical precedent for this kind of cooperation, we think about the International Space Station. On the International Space Station, we have our partners, international partners. We also have commercial partners. Tremendously valuable capability from a diplomatic perspective, tremendously valuable capability from an economic perspective, especially as you think about the commercialization of low Earth orbit activities. The International Space Station is a tool to get all of that done. The difference between the International Space Station and what we're trying to build with this reusable, sustainable architecture between the Earth and the Moon is that the International Space Station is massive, and so we can put lots and lots of partners on there, commercial and international. When people think about what we're building to the Moon, they equate it in their brains policy-wise. They think about Gateway, which is that reusable command module, and they say, well, we want to participate in the reusable command module that you call Gateway. And they think of it like the International Space Station. Gateway is not the International Space Station. It's much smaller. We cannot load Gateway up with international partners and commercial partners the way we've loaded up the International Space Station with those partners. So that being said, when we think about Gateway and we want to lead an international coalition of capability around the moon, we don't want all those partners necessarily on Gateway. We want those partners building launch vehicles to get into Earth orbit. We want those partners building tugs to get from Earth orbit to lunar orbit. We want those partners building tugs that can get from that near rectilinear halo orbit around the moon to that low lunar orbit. And we want those partners building landers. Dissimilar redundancy from international and commercial partners in the entire architecture. So rather than building a space station with commercial and international partners, we're building an entire architecture that's sustainable to the moon, and our international and commercial partners are going to plug into that architecture in ways that historically we've not been able to do as a country, let alone as a world before. Some of the benefits we have right now with our international partners, there are now more international partners on the face of the planet than have ever existed before, and they are all super excited about going to the moon. More so than the excitement I get in the United States of America. In the United States, we landed on the moon 6 times. We've had 12 humans on the surface of the moon. And so for us, it's, hey, we've done this before. Well, in these other countries, they've never done it before. They are so excited. They're thrilled that the United States of America is leading this effort because they want to partner with us. So that's really what that first part of Space Policy Directive 1 is about. Innovative and sustainable program of exploration with commercial and international partners to enable human expansion across the solar system and bring back to Earth new knowledge and opportunities. I'm going to anchor for a second on the third word there, international. Why is the United States so invested in having international partners when we build these architectures? Why are we so invested in international partners when we decided to build Space Station Freedom, which became the International Space Station? And this is, I think, lost by a lot of policymakers here in Washington, D.C. NASA is a critical piece of American foreign policy. It's a critical piece of American national power. I'm talking about soft power. So when you think about the national space policy, this is Space Policy Directive 1, and all that is an amendment to the national space policy. So what is the national space policy about? What is that for? Well, that is to help shape the world. Any national policy is to help shape the world in a way that is supportive of American interests. That's the purpose of international policy to begin. What are America's interests? What are vital interests? And then what are the things that we'd like to lead on? And so when you think about national policy, that's what we're trying to do, is we're trying to shape the world to the benefit of not just us, but to everybody, quite frankly. And international cooperation is a piece of how we do that. So we think about what are the ends of that policy. Pick any country that the United States has relationships with. One country, of course, that I recently got back from was Russia. I was over there for the launch of a cosmonaut and an astronaut to the International Space Station. It was a failed launch, but everybody came home safely because the launch abort system worked as advertised. But the question is, so why is the United States, why are the United States and Russia involved in this partnership when in so many other ways terrestrially our relationship breaks down? And we have disputes on borders, whether it's Georgia, South Ossetia, Abkhazia, Ukraine, Crimea, other treaties that we're involved in, the INF Treaty for intermediate range nuclear forces, all of these kind of things. Big disputes, disagreements, each country accusing the other country of meddling in elections. These kind of things, of course, anti-satellite missile launches. These are big things, and yet when it comes to space exploration, somehow it's in America's interest and it's in Russia's interest to cooperate. The question is, why is that? Well, we as a country, we have end states in mind that we would like to achieve. And in order to achieve those end states, there are ways and means to achieve those end states. One of the ways to achieve those end states is by using our instruments of power. So for everybody out there, I'm going to ask you to write the word midfield on a piece of paper. MIDFIELD, midfield. That's an acronym, and each one of those letters represents an element of national power, a tool of national power to help shape the world in a way that is beneficial to American interests. The M, of course, is military. People understand what the military is for. It's a last resort. We don't want to use it. It's on the table if necessary, but we don't want to use it. I is information. D is diplomacy. F is financial. These are all elements of national power that we can use to help shape the world in our favor. The second I is intelligence. E is economic. L is law, in this case, international law in particular. And then the last D is development. So midfield is the acronym. And so when you look at these tools of national power that we have to help shape the world and to help us advance our interests, what are those tools available to us? And where does NASA play? In my view, people know NASA plays on the diplomatic side. NASA is an amazing instrument of very soft power. We want people to cooperate with us. We want to do scientific discoveries together. We want to develop space collectively with other countries. NASA is a great way to do diplomacy with other countries. That first I in midfield is for information. NASA is also an amazing tool for information. And when I say that, I'll give a historical example. There was a day back during the Apollo program when the United States and the Soviet Union were the only two countries that participated in space activities. And during those days, our countries had tremendously different values, very different interests, and yet we had an interest in somehow communicating good things about the United States of America behind the Iron Curtain, which was the former Soviet Union. How do we get messages about what America is, who America is, how do we shape in the minds of the people behind the Iron Curtain, how do we help them understand that America is not this tremendously evil country that maybe they were being told that America was? Well, there are ways to communicate behind the Iron Curtain. In this particular case, if you go back to Apollo 8, our astronauts, this was on Christmas Eve, our astronauts on December 21st, 1968, they launched to the moon, and they flew in orbit around the moon on Christmas Eve. And they had the opportunity to communicate to the entire world from the moon on Christmas Eve. Remember, at the time, under the Soviet rule in the Soviet Union, the Bolsheviks came to power in the 1920s. Vladimir Lenin killed everybody who was a religious leader, and it didn't matter what the religion was. All religion was being outlawed. Churches were burned, mosques were burned, a lot of people killed, and then move forward to Joseph Stalin. He doubled down and tripled down on those activities. And so you had generations of people that had grown up believing that government was all there was, and religion was not just illegal, but it would get you killed. And here we had 3 Americans in orbit around the moon, and they were exercising their First Amendment rights. And nobody told them what to say, as a matter of fact. All they said was, whatever you say, make it profound, because everybody on the planet's going to be listening to you. And on that Christmas Eve, taking great risk upon themselves, great risk upon the space agency, because if that mission would not have gone well, and NASA had declared it was a 50-50 chance they were going to come home alive, but if that mission had not gone well, it would have not only been disastrous for the way people think about the moon, it would have wrecked Christmas for everybody in the United States of America. And yet they took this risk because they were trying to stay ahead of this. They were trying to get ahead of the Soviet Union. And when they keyed that mic on Christmas Eve, this is the important thing. 1 out of every 4 people on the planet were listening to that broadcast. 1 out of every 4 people on the planet were listening to 3 American astronauts in orbit around the moon on that broadcast. And if you go forward in time from there, if you think about the people who listened to to the replay of the broadcast, and you think about the people who listen to the replay of the replay of the replay of the broadcast, I don't know, probably everybody on the planet almost heard that broadcast. And when they keyed the mic, without any direction from the U.S. government, the 3 astronauts read Genesis 1:1 through Genesis 1:10. And behind the Iron Curtain, where it was illegal to talk about God, people were hearing Americans freely talking about God. It's really an amazing kind of story, and not a story about religion, but a story about freedom, and really a story that kind of shaped how people in another country thought about people in our country when they were living behind the so-called Iron Curtain. That was an amazing moment in history. And then you go forward 6 months from there, 7 months from there, to when we had Neil Armstrong and Buzz Aldrin on the surface of the moon. And when they stepped on the moon, they declared, again, the audience even bigger this time, humans on the surface of the moon. It wasn't 1 out of every 4 people on the planet. It was even higher. I don't know what it was, but now eventually everybody on the planet probably saw it. Neil Armstrong said this is 1 small step for man, 1 giant leap for mankind. They're seeing American astronauts on the moon talking about mankind. And so what NASA has the ability to do is reach into countries and share concepts and thoughts about who we are as a people that helps people maybe see us differently than their governments would like them to see us. And that's I think, a very powerful tool of policy that NASA is for the U.S. government that sometimes gets overlooked by our leaders. And so I think that's an important takeaway. Now we think about where we are today. No, we're not trying to share images or messages with people behind the Iron Curtain. Those days are over. And I think everybody on the planet is grateful for that. But what we are trying to do, I love it when Dr. Jim Green comes into my office and says, hey, guess what? There are complex organic compounds on Mars. We know that because of the Mars Curiosity rover, and it has on board international partners from all over the world that helped us to make this discovery. And then that particular discovery ends up on the cover of every newspaper on the planet, and people are seeing what America is doing in conjunction with our international partners, and it has the ability to help shape the image of America in the world to our favor, so that it makes it more difficult for us to be demonized in other countries. And this doesn't solve all of the problems, but certainly there are many countries, small countries, that have, in some cases, populations that are easily and readily radicalized. And we want those countries to be partners with us as well, because we want to be on the cover of their newspapers partnering with us, whether it's an astronaut program or a program to build a sustainable architecture to the moon. We want those positive stories about the United States of America in countries that generally don't get positive stories about the United States of America. And that would include, you can pick your countries today, but Iran would be top among them, and other countries that where the leadership is not keen on saying nice things about the United States of America. So the goal here is a tool of soft power. Diplomacy, I think everybody understands. It's pretty transparent. The information piece, I think a lot of people don't understand, but I do think it's a very critical element of national soft power to make sure people understand that America is filled with really amazing people, like Dr. Jim Green and Greg Schmidt and so many others, and people on this broadcast, the people that are watching this, who are going to be making the discoveries of the future. Another great example, I was in Congress in 2014 when New Horizons did its flyby of Pluto. There wasn't a newspaper on the planet that didn't have that mission on its cover. The first images of Pluto, we knew it was there. We had an idea. It was a blob that we, had some idea, maybe what we really knew was nothing. And all of a sudden, we're getting these beautiful images of this planet, although not a planet anymore, but we're getting these beautiful images of this dwarf planet that is making the cover of every newspaper all over the world, and it's an American mission with help from international players that made it a reality. So those are the kind of very positive things. That's why that international piece is in Space Policy Directive 1. International, NASA can do some really amazing scientific things, and there's a reason for doing that all alone. But apart from that, there's a reason that we have a communications department to make sure that all over the world our capabilities are being demonstrated and shaping people's image of us. All right, I think I've beat that dead horse enough. So those are some of the key capabilities. The midfield acronym is an acronym that those are elements of national power that can help shape the end states. Those are means of national power to help shape the end states so that the United States can operate and function in a world that's to its favor rather than opposed to it. Another important thing here, the word utilization is underlined in Space Policy Directive 1. That's a brand new kind of concept as a policy for the United States. We're not just going to go to the moon. We're going to utilize the resources of the moon. We know from a mission from India back in 2008, we know that there's water ice on the moon. From a mission from the United States, from NASA, 2009, we know now that there are potentially hundreds of billions of tons of water ice on the surface of the moon. And the question is, now that we know that, what does that do? Well, water ice, of course, is life support. It's air to breathe. It's water to drink. It also represents propulsion. You crack it into hydrogen and oxygen, you put it into cryogenic form, and that's the same propellant that powered the space shuttles. It's the same propellant that will power the Space Launch System. And here's the glory of the moon. The moon has no atmosphere. So to launch things off the surface of the moon, it's not that hard. I mean, you go back to Apollo and you look at the clunky-looking gear that we landed on Apollo, and you look at the clunky-looking gear that landed on the moon, the clunky-looking gear that launched off the moon. It's not aerodynamic. There are no fairings. It would certainly never be able to fly within Earth's atmosphere, and yet on the moon it works. And the other thing with the moon is the gravity well is 1/6 that of the Earth. So these things collude to say, look, if we could take advantage of this very unique resource on the moon, which is life support and propulsion, put it into cryogenic form and put it into orbit around the moon, now what can we do with it? And there is no shortage of ideas on how to utilize propulsion from the surface of the moon that would not only be good for NASA, but be good for the economy. Imagine if, for example, we could, I'm just throwing this out there, but we've got $500 million satellites in geostationary orbit that are doing things like delivering DirecTV, Dish Network, and internet broadband from space. Well, those $500 million satellites in some cases only last 5 to 10 years. Other cases, they can last 15 years. But why do they? What is their limiting factor? Their limiting factor is station-keeping fuel. And of course, it doesn't make sense to fuel them from Earth because it's so expensive to make all that happen. So what do? They take these $500 million investments and they just park them in deep space. They super sync these satellites. That's a massive waste of resources. What if instead you could use the fuel from the moon where there's no atmosphere and Jim's going to correct me on this, maybe there's very tiny amount of atmosphere? Very tiny. So either way, it's irrelevant from an aerodynamic perspective. And then of course the gravity well is 1/6 that of the Earth. What if you could actually produce some kind of station-keeping capability from the surface of the moon that would be far more cost-effective than launching that capability from the Earth, and move that with a tug from lunar orbit down to Earth orbit. And when I say Earth orbit, we're talking about geostationary orbit, so very high Earth orbit. and actually be able to make those satellites last instead of 5 or 10 years, make them last 15 or 20 years. Again, I'm not saying it sounds very science fiction, but what NASA does is science fiction. And if you would have told people 40 years ago that we were going to have an international space station in orbit with people on board for 18 years, they would have told you that was science fiction as well. So these are things that I think NASA needs to be thinking about economically, which is, of course, policy related. And I think the last word there that I underlined is the word Mars. All of these things that we want to do around Space Policy Directive 1 and getting to the moon are really to retire risk, to prove technology and prove capability, prove human physiology, and use all of that, replicate as much of it as possible for a sustained trip to Mars. So the moon is, in essence, the best proving ground to get to Mars. We think about, I've heard people say, from a policy perspective, since we're talking about policy, people say, every dollar you spend getting to the moon is a dollar you're not spending getting to Mars. I've heard that over and over again. The challenge with that thought is, imagine if you're the astronaut. We know what happens to humans when they're in low Earth orbit for a period of 6 months to a year. Your bone mass, you lose 1 to 3% of your bone mass every month. Your neurovestibular system, of course, gets thrown way out of whack. Your heart gets deconditioned. There are other challenges with cranial pressure in the skull that can affect eyesight and other things. And of course, if you're flying to Mars for 6 or 7 months, you're going to be pelted with radiation for 6 to 7 months. And how does that affect the human physiology? We honestly don't know. But we're going to do all of these things on a 6 to 7 month journey to Mars. And then when our astronauts get there, we're going to tell them, you have to be absolutely perfect because you have to be on Mars for the next 2 years. And you can't make any mistakes because now Earth and Mars are no longer aligned. So you have to wait 2 years before you have an opportunity to come home. I think it would be irresponsible to try to prove all of the technology, reduce all of the risk, prove the human physiology all for the first time at Mars. Instead, imagine if we had a moon. We could use the moon to prove all of this stuff, to demonstrate it. The glory of the moon is this. It's part of the Earth-Moon system. That's a big deal. The moon is always with the Earth. It never leaves. It's here. And it's a 3-day journey home. And if Apollo 13 taught us anything, it's that things can go very bad on the way to the moon and you can still make it home safely. If something like that happens on the way to Mars, you're not coming home. So the moon, as a matter of national policy, the moon is our best opportunity for the most success to get to Mars. And what we don't want to do is we don't want to have an unsuccessful Mars trip the first time, because that will prevent a second Mars trip. The moon is our best opportunity to reduce the risk, prove the technology, prove the human physiology, and then take as much of that as possible, the technology, and replicate it for Mars. And that's what we're building. That's why we're building the sustainable lunar architecture with commercial and international partners. We're going to utilize the resources of the moon. Going back to utilization for 1 second, we talked about the water ice, how valuable it is. Potentially. It's certainly valuable for life support, without question. This is the other thing that's of interest from a policy perspective. It was Goldman Sachs that did a study not too long ago, and they determined that the world's first trillionaire, if you can imagine somebody being worth $1 trillion, the world's first trillionaire will be somebody who exploited resources from space. In other words, they're saying precious metals. We don't know what we don't know, but here's what we do know. We know that Earth has precious metals. We call them rare earth metals. We also know that they're not earth metals at all. They're impacts of asteroids from billions of years ago embedded in our planet. Well, the challenge with the Earth is we have this very active geology, and we have a very active hydrosphere. And so an impact from 2 billion years ago is not as easy to find, and it's certainly not in the same condition that it would have been 2 billion years ago. But the moon, where there's not an active geology and there's not an active hydrosphere, whatever hit there is probably right where it was when it hit. Now, it doesn't mean that we're going to find anything, but it does mean that there are people interested in finding things, and it's incumbent upon us to allow them to do so if they're interested. And if we can build an architecture with commercial and international partners that makes it easier for other people to invest capital and expend their energy trying to make those discoveries, it'd be great for the United States of America to be at the helm of those discoveries. Because $1 trillion, by the way, if it's there in $1 trillion, it's probably there in multiple trillions of dollars. That can change the balance of power on Earth. And NASA doesn't want to be responsible for ceding that leadership to a country that's not always friendly to the United States of America. So when we think about policy, utilization is not just about the water ice. There are other reasons that might be. It's important for, and again, I'm not saying we're going to find anything, but what I am saying is it's important for, if we do find something, it ought to be us that finds it from a matter of national policy. Okay, so all of that is embedded in Space Policy Directive 1. More than you ever wanted to know. And I'm going to open it up for questions here in a few minutes. But in order to be, if Space Policy Directive 1 is going to be successful, commercial is a big piece of that. And if commercial is going to be successful, we have to have the regulatory environment to enable it. And that's what Space Policy Directive 2 is all about. It's all about creating a regulatory environment where companies have the ability to invest here in the United States, to develop capability here in the United States, and to launch from the United States to do activities. From a policy perspective, one of the challenges that we have is that the United States of America is responsible under the Outer Space Treaty to provide authorization and continuing supervision for all activities that launch from the United States of America. So when we think about commercial habitation in low Earth orbit, commercial space stations in low Earth orbit, to do manufacturing, maybe of, I don't know, various materials, or to do, now we're testing things on the International Space Station like 3D printing of human organs for life-saving capabilities. Like these things, when they are successful, because I believe a lot of them are going to be successful, there's going to be a commercial market for habitation in low Earth orbit. So the question is, who in the United States government is responsible for authorizing and continuing to supervise habitation in low Earth orbit, which is required under the Outer Space Treaty? Right now, we don't have an agency in the federal government responsible for doing that. Same thing with rendezvous and proximity operations to do in-space servicing of satellites. There is no federal agency responsible for authorizing and continually supervising rendezvous and proximity operations to in-space service satellites. And by the way, in the international community, people see that as very provocative because it could have dual use capabilities. In other words, not just to service satellites, but also damage satellites. And then, of course, when you think about going to the moon or going to asteroids to mine, who in the U.S. government is responsible for authorizing and continuing to supervise those activities? Right now, there isn't anybody responsible for that. So Space Policy Directive 2 is to create a regulatory environment for the commercial use of space. And for these activities, what the administration is focused on doing is having these activities ultimately end up at the Commerce Department, which I support. When you think about why people came to the New World to begin with, it was for commerce. When you think about why people in the New World expanded west, it was for commerce. When you think about why people are going to expand into the solar system, it's because of commerce. So I think it's a good idea that the Commerce Department be responsible for making these regulations in order to, again, the key here, we have to be very careful because this would be regulatory in nature. We want a minimum regulatory burden, but we want a maximum regulatory certainty. Right now we're in a situation where we don't have an agency that's responsible for doing the authorization and the continuing supervision for these activities, which is required under Article 6 of the Outer Space Treaty. We don't have an agency responsible for doing that. So what happens is The State Department specifically tells people that are wanting to do these activities that they can't launch, that we don't have the authority under the Outer Space Treaty to allow them to go into space. So what happens to that capability? Well, it goes abroad. It goes to countries like Luxembourg or the United Arab Emirates, where they're more proactive on these kind of activities. And so it is in our interest as a country that those activities stay here. We want investment coming to the United States, not leaving the United States. We want our international partners to be successful as well. Don't get me wrong, we're not competing against Luxembourg or UAE, but we're going to be able to do a lot more in space than either one of those countries just because of the size of our economy and things like that. And we don't want to squash it because we don't have the right regulatory policies in place. In order for all, to the extent that we're successful with these activities under Space Policy Directive 2, then the commercial elements of Space Policy Directive 1 can be successful. Because commercially we're going to need habitation, we're going to need rendezvous and proximity capability, and we're going to need capability to utilize the resources of the moon commercially and utilize the mining of asteroids and those kind of things. So Space Policy Directive 2 is necessary for the success of Space Policy Directive 1. Although Space Policy Directive 2 is not a NASA function, it will help NASA accomplish its objectives. And then, of course, Space Policy Directive 3 is focused on situational awareness and space traffic management. That in itself is probably a one-hour lecture on its own, which I'm not going to start going into here. But just know that this is long overdue. The international law and regulation on this doesn't exist. And yet, if we don't get it right, we're going to destroy low Earth orbit for the long haul. The Interagency Space Debris Coordination Committee, of which NASA is one of, I think, 15 agencies at this point, they have determined that every 5 to 9 years we're going to have a collision in low Earth orbit similar to the Iridium Cosmos collision that we saw back in 2009. That collision resulted in thousands of pieces of orbital debris that are currently trackable by the Joint Space Operations Center, which is operated by STRATCOM, Strategic Command. And the challenge is, well, there's a lot of challenges, but that study said every 5 to 9 years we're going to see a collision on that scale. It also said that's if the launch cadence stays the same. Well, the launch cadence isn't going to stay the same. We're going to see massive constellations of thousands of satellites in low Earth orbit for low latency, high throughput communications, things that we've never seen before as a country or as a world, things that will improve the human condition on Earth, things that we need to be successful. But those kind of things, if we don't have the right space policies for situational awareness and space traffic management and the right international regulatory regimes, if we don't get it right, we will destroy low Earth orbit for all of humanity. And that will decimate the human condition on Earth. The way we communicate, the way we navigate, the way we produce food, the way we produce energy, the way we do disaster relief, the way we predict weather, the way we understand the climate. If we come to a day where low Earth orbit is destroyed entirely, all of these things are no longer going to be elevating the human condition to the tune of, I don't know how many trillions of dollars, but it's an amazing capability that is available to humankind because of space. And if we don't figure out this piece, we could wreck it, which we don't want to wreck it. We want to make it better than ever. So that's really the focus of Space Policy Directive 3. Okay, I'm going to stop talking at this point and just really allow people to voice their opinions, concerns, ask me any questions, and go from there. I probably put everybody to sleep at this point.
No.
Not at all, Jim. But thank you very much for a very articulate, educational, and inspiring discussion. This is just exactly what we needed to hear, and it gives us great hope for the future here in terms of lunar exploration and beyond, and Mars and beyond. And we do have a series of questions, and we'd like to address a couple of those. And Ariel Deutsch, a NASA fellow and a SSERVI participant, will be asking the questions. Ariel?
So Our first question is, what is the quickest timeline for getting NASA astronauts to undertake scientific exploration? All of the students in our class are eager to explore the lunar surface.
That's a wonderful question. I would say, we are looking at launching EM1, Exploration Mission 1, which is the SLS rocket with an Orion crew capsule. Although EM1 is going to be uncrewed, it will deploy the it actually won't deploy. EM2 will deploy, that would be in 2022, will deploy the first element of the gateway in 2022 around the moon. EM3 will deploy human habitation to the gateway in 2023. So we will have in orbit around the moon habitation for human activity in 2023. We're looking at having, in parallel to building the gateway, which is that reusable command module in orbit around the moon, we're looking at having the development of human landers at the same time. So I think it'll probably be around 2028 by the time we have human activity on the surface of the moon again. But between now and then, here's the other thing about the gateway. It's not just about human activity on the surface of the moon. Our astronauts on the gateway are going to be able to robotically control all kinds of activities on the surface, from rovers to landers to robots, and be able to learn and understand more about the moon than we've ever been able to understand before. This is an important point, and it goes, I think, right to your question. When we think about the history here, 1969, we landed humans on the surface of the moon for the first time, 1969. 2008 is when we knew that we knew. Actually, even in 2008, we didn't know that. 2008, we were highly confident that there's water ice on the surface of the moon. 2009, we knew that there was water ice on the surface of the moon. 40 years. And during those 40 years, a lot of people believed that the moon was absolutely bone dry. And the question is, why did they believe that? Well, our 6 missions to the surface of the moon were to that equatorial region of the moon where it was, in fact, bone dry. And the samples that came back were, in fact, bone dry. The gateway is different in the sense that it's a reusable command module for the long term. Are you telling? You think that's wrong?
The samples are not entirely bone dry.
Okay.
Turns out
Some new research from SSERVI.
yes, from SSERVI and in fact from folks at Brown that have found that we have good enough measurements now that there is actually water native to the moon in
those samples.
In some of the samples.
Okay, so
very small amounts, but there is actually water. Yes.
So those samples were not bone dry.
They were
but
not as bone dry as we were expecting.
In 1972, what did we believe about those samples?
We didn't have the resolution yet with the samples, which is one reason why samples are really important, because we can, as our technology gets better, we can learn new things from samples. So the samples, the way we were testing them in 1972, we didn't have the resolution to see this water. We had to wait until the 90s.
Okay. What's critical, but also the point, M cubed brought us back to that, hey, we need to look at this again. M cubed, and then, the concept of water in permanently shadowed craters.
So M cubed being the mission that was the Indian mission.
Mission, that said, okay, look, there's potentially hydroxyl in water, and you see more of it as you go to higher and higher latitudes. Maybe we need to go back and relook at the Apollo samples. Okay, so got it. So there is, I guess, in the samples, because of research done by SSERVI, we now know, because I guess our resolution is higher now, we now know that there was very, very trace amounts of water even in those original samples that we didn't know back then, but we now understand. Okay, so bottom line is this. What else are we going to learn about the moon? Had we in 1969 landed on the poles of the moon, there would have been no doubt. Like there's a lot of water ice here. Now that I understand that landing on the poles of the moon is very different than landing on the equatorial regions of the moon. And I also understand that Jim, who is kind of honchoing this, was responsible for helping us
determine those landing sites. So thank you, Jim, for all of that.
Well, the SSERVI group really pulled that together for us.
The SSERVI group, absolutely. So this is a big deal for us. We want to get to the surface of the moon. We want to have more access to more parts of the moon than we've ever had access to before. That's why the gateway is important, because it is in that near rectilinear halo orbit for a long period of time. It has solar electric propulsion. It can get to the L1 point and the L2 point, and it can actually deploy landers and rovers to more parts of the moon than we've ever been able to deploy anything to before. And in many cases, have low latency telerobotics, so we can actually, in some cases, maybe even go deep inside a lava tube on the surface of the moon, dropping behind the rover, dropping behind communication repeaters. Those kind of things are going to be tremendously valuable uses, I think, of the gateway with humans in orbit around the moon in a way where you don't have to wait 3 seconds for the signal, but instead it can be a much more real-time kind of.
Yeah, and the gateway also has the ability to acquire samples lofted up from the moon.
Yeah.
So that's an element of their science requirements.
Yep.
And then they can bring them back.
Yep.
That makes the concept of bringing more and more samples back from very diverse sites realizable.
Absolutely. So I think to answer your question, I would say if you want to be on the surface of the moon, probably 2028. But
Okay, everybody's getting the resumes together.
Just talk,
you have one more?
Talk to your member of Congress about increasing our budget.
So our next question is, how can the rockets that are being built by commercial companies like SpaceX and Blue Origin be incorporated into the NASA program to get humans to the surface to explore the moon? And can these rockets go directly to the moon to complement the gateway?
The answer is yes. We want to utilize commercial as much as possible. The architecture is open. Gateway is largely going to be government owned and operated, but it itself will have commercial components on it, things that we're acquiring commercially. In fact, we're going to acquire the power and propulsion element commercially, potentially, the habitation module commercially, potentially. We're working through all of this right now, but eventually the answer is yes. Commercial launch providers we will benefit from commercial capability to get not only to the gateway, but all the way to the surface of the moon. If companies want to go on their own, we're for it. If they don't want to use the gateway, certainly NASA would love to be a customer. We're doing the Commercial Lunar Payload Services program right now, which is being driven from the Science Mission Directorate, which is kind of unique in itself. We've got the Science Mission Directorate funding lunar landing activities for very small payloads in a commercial way. We're going to do an IDIQ kind of contract. In other words, indefinite delivery, indefinite quantity contract for commercial companies to deliver payloads to the surface of the moon so that NASA can say, okay, we have this instrument. We want to get this instrument to these 5 positions on the surface of the moon. We want to know what company can deliver this for, say, I don't know, $30 million each. And then it's up to those companies to go raise private capital, to find other customers, and then NASA is one customer of many customers, driving down our cost and increasing our access. But all of that could be done. It will be done. The Commercial Lunar Payload Services will be done commercially, and we're going to have announcements on those activities in the coming month. So that's going to be a big announcement. So yes, we want commercial. And in some cases, commercial is going to be interested in utilizing the capability of the gateway. In other cases, commercial will not be interested in utilizing the capability of the gateway. In all cases, NASA will be interested in using that resource that commercial can provide.
That's excellent. I think some of the students were wondering more of it as a partnership. So, for example, SpaceX or Blue Origin's, as you said, you're going to be developing the capability for human landers to the surface, and it's nice to see that those plans will be developed in parallel, both from the gateway maybe with international partners, but also commercially, say, direct to the surface from the Earth, because as you well know, some of these rockets, like the Big Falcon rocket, et cetera, are capable of delivering those landers to the surface. So that would be great to have it complement the Gateway. Excellent. Next question.
Yeah, absolutely. And if you look at how we did commercial crew and commercial resupply to the International Space Station, those were really strong partnerships that are ongoing today. We want them to be successful. And if there are opportunities to do those kind of partnerships to the moon, we're open to it. And of course, those companies are interested in doing that. We need to maybe see a little more meat on the bones before we're willing to jump off and put hundreds of millions of dollars into it. But no, we think that's a great concept. We've actually proven that concept in the past. And if we can make that successful, we would be for it.
Excellent. Ariel?
How does
To be
NASA
clear,
work
Jim,
to convince
I
taxpayers and the general
sometimes I hear
public?
people say that Gateway is going to prevent us from getting to the surface of the moon, or Gateway is going to prevent us from having commercial access to the moon. And I utterly reject that. This is not, Gateway is not a competitor for a commercial capability to get to the surface of the moon. Gateway is an enabler. Its utility is not just for access to the surface of the moon, but for access to orbits of the moon that we need to have access to get to more parts of the moon than we've ever been able to get to before. And as Jim said, even flying through plumes that we might potentially create on the moon. So, yeah. So, but I have heard that Gateway competes against those commercial things, and it's not true. That's not the intent here.
That's excellent. Thanks very much for the clarification, and we're really excited that there might be two pathways, very complementary, with the Gateway and commercial human landers to the moon, because we understand from what you've talked about previously that you were looking to international partners to participate in maybe human landers from Gateway to the moon. So that's a great array of potential exploration of getting all these students to the moon so they can explore scientifically. Thanks. Ariel?
Yes, we want all the students to go to the moon and come home.
How does NASA work to convince taxpayers and the general public of the value of initiatives like Gateway?
That's another important question, and it's not always easy. What the taxpayers need to be convinced of is not that Gateway itself is the solution, but they need to be convinced of the value of the moon. And there is a value of the moon that goes well beyond science, and it goes all the way into a national soft power capability that we talked about a few minutes ago. When I go to international fora, I was at the IAC just last month, talked to 4,000 people, and I said, look, it's time for us to go back to the moon. And it was an instantaneous, spontaneous, rousing applause. You don't get that in the United States. I don't get that in the United States. Maybe you guys do. I don't get that in the United States. But internationally, there is so much excitement for the United States to lead an international coalition to the moon. It is palpable. I'm a rock star when I go to these foreign countries because of the whole moon thing. And I think one of the ways we convince Congress that what we're doing is important is enable them to see how important this is from a diplomatic and an information perspective, to exercise those elements of American soft power so that people see what America is and what we're doing, that we want them to join us in these scientific and exploration and development initiatives, and have them understand that what they see on the evening news isn't always all that America is. We're a lot more than, because in a lot of these countries, and a lot of you have maybe traveled around the world, their evening news is about bombs that fell in Syria. And in some cases, those aren't our bombs. But that's not what the evening news presents in these countries. We need to make sure that we're getting messages about who America is and what America is that are not just propaganda from certain governments.
Ariel?
It sounds from your description that Gateway not only encourages international collaboration, but really requires it to be useful. So how will NASA work to ensure that international investment is a part of the Gateway collaboration?
Yeah, so that's what, when I go to the IAC, I go to the Farnborough Air Show, I always host multilateral discussions about what the architecture might look like. And right now we're starting to figure out what the different interests of the various countries are. So when I was in Bremen, Germany at the International Astronautical Congress, I had a meeting with all of the heads of space agencies that were there. And in that meeting we had, I think, probably 24 different heads of space agencies. And we had a long, detailed conversation about what this lunar architecture is. And here, the response I get from so many different countries is, and this is a surprise to me. When I became the NASA administrator, I did not expect it. The surprise was this. They say, we're with you. Tell us what you need us to do, and we'll go sell our governments. That's what the heads of space agencies say to me. And I haven't heard it just once. I've heard it over and over again. That's a very positive thing. It demonstrates that America is a leader here. It's a position we want to retain. But what we have to figure out is, you can imagine, there's a lot of countries that want to own a habitation module on the Gateway. Well, if the Gateway gets too big, solar electric propulsion is no longer going to be able to maneuver it. So not every country can have a habitation module on the Gateway. But what countries generally like to do is they like to have these transparent, salient, visible kind of pieces of the architecture that make their politicians back at home look good. That's what they're looking for. And I know this because I used to be a politician. So where I think we can help is, and we've done this, we went out to all of these international partners after this meeting. We said, please put on paper for us what you would like to do. And different countries are really good at different things. Canada is really good at robotics. They're really good at the Canada arm, whether it's the International Space Station or the Space Shuttle. Canada has these capabilities. So we need to figure out what countries are good at which pieces and then start putting them together. Now, there will be disputes. Without question, we know there will be disputes. Some countries all want to play in the same area. The reality is not every country is going to have the budget materialized to play in certain areas the way they'd like to. So we're working through it. It's not easy. I will tell you this, and I work for an agency that is amazing, and they've done it before. If you look at the International Space Station, that's not just a marvel of technology, it's a marvel of international diplomacy. I mean, it's the space station is a treaty in itself. And talk about I don't know how they did it, quite frankly. I'm trying to figure out how in the world they put together the international coalition in a way that actually worked. But there's a lot of people here at NASA that were around when that was done, and I'm going to put them to work because we've got to do it again. We've just got to do it bigger with more space agencies than ever before, and figure out how to integrate commercial into the architecture as well. So I don't know if I answered your question. I guess the right answer is just a lot of really hard work.
Great. Ariel?
China is now exploring the moon and has plans to explore Mars in the future. Is there a chance that NASA will cooperate and collaborate with China in upcoming space missions?
In some ways, yes. And in fact, we've already started opening these dialogues. Science is not, when you talk about what China can learn at the moon, well, we want access to that information as well, not because it's going to give us any kind of strategic leverage or advantage, but because it's science and people are interested in it. And when we go to the moon, they're going to be interested in what we learn from the moon, just from a pure scientific perspective. So when it comes to sharing data, when it comes to sharing information, I think certainly there's a lot of ways that we can collaborate on the scientific level. We are prohibited by law, as you're aware. We're prohibited from cooperating with China bilaterally on development of technology and capability and that kind of thing. They're not, for example, permitted to participate in the International Space Station, and that creates a big challenge for me as the NASA administrator. What has happened here, from a policy perspective, is that they hacked into the wrong person's computer. And it ticked off the chairman of the Commerce, Justice, Science, Appropriations Committee, and Frank Wolf cut him off. But when it comes to cyber espionage, when it comes to cyber attacks, when it comes to developing islands in the South China Sea, when it comes to putting integrated air defense systems on those islands, in other words, weapons, when it comes to putting air defense identification zones over the Senkaku Islands, which internationally are disputed. A lot of people would say those islands belong to Japan. When it comes to launching direct ascent anti-satellite missiles, when it comes to doing co-orbital anti-satellite activities, satellites flying in formation with other satellites, jamming, spoofing, hacking, dazzling, all those kind of things. Everything I just mentioned is published in open source periodicals. Those kind of provocative activities don't make Congress happy. So the question is, what do we do about it as a country? Is cutting off NASA's cooperation the right approach? I would argue probably not. And I say probably not because we are an element of soft power where we can cooperate diplomatically and we can cooperate on the information side of things. People can see that the United States is doing amazing things in cooperation with China. Those kind of messages can be distributed back inside of China. One of the challenges that we have with this particular law, since this is all about policy, one of the challenges is, and I've been on the other side of this, as a member of Congress, what member of Congress wants to go into a debate with their opponent and say, yeah, I believe that in this particular term, now is the time to go soft on China, as they're violating human rights and those kind of things. It's politically untenable for anybody on either side of the aisle. That being said, this policy is a matter of law. As the NASA administrator, I follow the law, and to the extent that that law changes, it enables us to be an element of that soft power. But right now, that law hasn't changed, and I'm going to follow the law 100% all the way every time. So I do believe that when Congress gets involved in doing these activities, it takes off the table a tool of soft power that can help modify and shape the behavior of competitors, in this case, China. I think we ought to have on the table the tools necessary to modify and shape behavior and not take those tables off the tool. In other words, if we want to not cooperate, that should be a decision of the executive branch, not the legislative branch, because when the legislative branch does it, then it can't be used as that tool that's necessary to modify and shape behavior. Just my policy perspective on it.
I think that's really excellent. Thank you very much for the clarification and the hope for the future as well. I think your point about the soft power is really, really critical here. Our experience with our Chinese colleagues and professional meetings, et cetera, is that they're very anxious to interact on their robotic missions to the moon and Mars, and they've been very forthcoming in sharing of data with us, and they've even, in a trilateral sense, not in violation of the Wolf Amendment, let us participate with some input and discussions on their upcoming landing sites for Chang'e 4 and 5. And so we're very excited about that. In fact, from from the soft power point of view, I think it really does have an effect. They have great respect for us and our accomplishments scientifically in Apollo and other lunar missions. And I think that as we explore things in the future, we don't have a way to facilitate this, but it's driving them into hands, into the arms of these hands and other powers that in a software way that we're not be able to do. So I think to find a way to support the base is very helpful in the soft power sense. So we have an additional question.
How can we maximize useful progress on our space exploration goals in the face of rapidly changing administrations and potentially shifting priorities?
So we're having some comms issues here. My understanding is how do we? So did you guys hear? I don't think anybody got. I think it was about when we changed from one administration to the other. How do we keep continuity or something like that? Is that?
Yes.
That is okay. So it's an important question, and I was involved in this as a member of Congress. I drafted a very comprehensive space policy reform bill. We called it the American Space Renaissance Act, and we addressed this as one of the provisions in that very comprehensive bill was how do we select a NASA administrator to make it apolitical and bipartisan. This was done, this was a bill I dropped back in 2016, and the idea that I had in the bill was that there would be a bipartisan group of 21 people selected by various elements of the government. So these 21 people would be selected, some by the House, some by the Senate, some by Republicans, some by Democrats, some by the administration, but it would be very bipartisan, and their objective would be to give options to the president as to who the president might pick for the NASA administrator. And the president would pick from among those various options. And the idea would be that the term of that NASA administrator would be for a period of 10 years. In other words, it would cross administrations so that we don't get these ebbs and flows when we go from one administration to the next administration. So this was this was a small part of a very comprehensive bill that I did back in 2016. And I thought that would help the situation because, like I said from the beginning, we don't want this to be Lucy in the football again. We have these starts. We're going to the moon. We're not going to the moon. We're going to the moon. We're not going to the moon. Now we're going to the moon again. We need to create the consistency. What you will find is that in 2017, the president signed the NASA Transition Authorization Act, which actually was done by Congress. Everybody says Congress is the problem. In this case, Congress actually did something good, and they created an environment where a lot of the consistency would be put into place. Not everything is exactly the same as it was, but it's really not that much different when you think about the technological development that's necessary. Before, we were doing the asteroid redirect mission, and now we're doing direct to the moon. But ultimately, the technology that's being developed for both is quite compatible. They're not exact, but they're quite compatible, and we're trying to make it as seamless as possible as we go from one administration to the next. But that bipartisan NASA Transition Authorization Act, I think, was important for setting the tone that we don't want to disrupt the direction that we were going as we move from one administration to the next. And what you'll find is that the president signed it into law and has been kind of promoting it ever since. It's actually been a great piece of legislation. So we're all in violent agreement that we don't want to end good things just because we go from one administration to the next.
Excellent.
If I may add,
So we have a question from an undergraduate student.
Environment, our government has made investment, encouragement, opportunities, and the commercial environment is responding. That will also be based on how successful we can work together and how far we can get between now and when the administration changes
Absolutely.
will really help us.
So that's a wonderful point, and it's not just commercial, but also international.
Yeah.
And in fact, there's a perfect example of this. The International Space Station today would not exist if it was not international.
Yeah.
Because it was international, because it was a tool of diplomacy and foreign policy, members of Congress voted for it. And when this vote took place, this was, I think, in the Sean O'Keefe era. It came down to like one vote. If I'm
One vote.
Golden, actually.
It was
Dan Golden's here.
Dan Golden.
He was here at headquarters.
Okay.
Yeah.
It came down to one vote, and the International Space Station was kept alive. So the international piece, I think, is an important element as well.
Great, thank you. We have one question from an undergraduate student here at Brown.
The commercialization of space has made space more accessible to the point that an undergraduate club at Brown now has a CubeSat orbiting Earth. Do you see a possibility for making lunar orbits accessible for CubeSats with the establishment of the gateway?
Absolutely, 100%, without question. The miniaturization of electronics is going to enable us to do more than we've ever been able to do before. We've got to be careful when we think about the moon. We don't want to create the orbital debris field around the moon that we have around the Earth. The moon is much smaller. It's very easy to clutter it compared to the Earth orbit when you think about low lunar orbit. But yes, 100%. I foresee lots of, we're sending CubeSats to Mars right now, or they're on their way to Mars right now for the InSight landing.
So why don't you mention a couple of the CubeSats our plans are for the moon?
Yeah, so we actually have CubeSats going on EM1. There are several of them that are being sponsored by HEO, the human side of the house, and there's one that's SMD, LunaMap, looking for hydrogen in the polar regions. I'm not going to remember all the HEO ones, but
the point is
we've started that process, and also that these CLPS contracts, right, the commercial lunar payload services, also allow for dropping off CubeSats, and some of these companies have that in mind in their plans for as a method for us to get CubeSats to the moon as well. And so it is definitely something we're thinking of. We're also thinking about student hardware. CubeSats are great because a lot of it is student hardware. They're talking about student hardware here, but like right now we have a call on the street looking for payloads for these CLPS missions, and one of the things we're looking for actually is student hardware for that too, especially these first missions. We already know they're going to be high risk, and that's a great opportunity for students to get out there and get some real practical skills.
Absolutely, and especially we think about that information piece. We talk about information as an element of national power that NASA brings to the table. When we could have international CubeSats from countries that would never otherwise have access to space, and not only that, but it would be their students that are building. And that's transformational in changing the perceptions of young people internationally about the United States.
That's excellent. So this was a Brown Space Engineering CubeSat that was launched just recently, and it's all student-built, student-run, and it's a very exciting opportunity for them to, change their vision to the moon.
Technology developments come every day, and one thing that I was interested in your vision on is, when you look at artificial intelligence, 3D printing, some of the cool stuff that Jason Cruzan is doing in his division, et cetera. How do you see that revolutionizing our approach?
Yeah, so when we live and work on another world, whether it's the moon or Mars, we're going to need to, we can't take everything with us. So we're going to have to be able to figure out what can we take and how do we maximize that. So those kind of capabilities and technologies are critically important for our survival on another world. I think when you think of other, the idea that the commercialization, like we don't know what we can do in a microgravity environment. Like it's unknown. Like we know that actually I should say this. We know we know a little bit about what we can do in a microgravity environment because of the International Space Station. What we don't know is what can we do, maybe not a microgravity environment, but a lower gravity environment like the moon or Mars, and what are the commercial capabilities that we're going to be able to discover there that we can't even do in a microgravity environment. So of course people, Andy Weir recently wrote the book Artemis, and there the big thing is fiber optics, and so capturing the imagination of the world with these kind of concepts and ideas I think is great. But I think there's going to be a lot of things that are going to be invented that we're not even thinking of by people that way smarter than me, and the last thing I want to do is get in their way. So there's a lot. I think there's a lot of opportunity out there.
Okay.
Well, Jim, thank you very much. I think if I could say a couple of words, Jim, before we go.
Schedule 2.
Jim Green.
And so let me thank everybody for the opportunity from NASA headquarters to be able to have this venue to talk to the administrator, understand what's happening from the very top gun. And let me turn it over to Greg to sign off.
Thanks, Jim. Jim Bridenstine, thank you so much. It's been just a great honor for you to share your vision, and I think that you've given a lot of excitement, not just to the students at Brown, but to all of us. We will tweet this lecture to all of our international partners and all of our domestic teams, and we just really appreciate you sharing this, and please keep us in mind. We want to know how we can help you turn this into a reality. So thank you so much.
All right, my honor. Thank you.
Hey, Jim Head.
Can I add one thing here, guys?
Absolutely.
Okay, so I just want to add my thanks to Jim Bridenstine for this incredibly educational conversation. It's just really impressive. The sense of history, the place of NASA in world affairs is really, really critical to all the future leaders who are sitting in this class here. So I would just say thank you very, very much, and I think you could add Professor Bridenstine to your resume for the future. Yeah. Thank you very much.
I would not presume to do so.
Well, thanks so much. We really appreciate it.
Thank you.